Hello everyone, this is the concept video of permutations and combinations, and we will be taking some questions as well. Now what do these images show? The first image is that of a number lock. Does this refer to permutations? And the second one is about selection. Is it something related to permutations and combinations both, or just combinations? Difference between permutation and combination. We'll get on to this in detail later on, but for now let us just read it once. Combination is the counting of selections. Whenever the word selection comes into question, it has to click in our mind that it is about combination. Whereas permutation is counting the number of arrangements. The key word for permutations is arrangements. These are the two examples of permutations and combinations. Fundamental principle of counting. As the word suggests, fundamental, basic, or the core principle of counting, it is very important to understand this concept to make a clear picture in our minds. Otherwise, we can face difficulties in understanding permutations and combinations. Now, this is an example of fundamental principle of counting. Mohan has 3 pants and 2 shirts. How many different pairs of a pant and a shirt can he dress up with? So P1, P2 and P3 are for pants 1, 2 and 3 respectively, and S1 and S2 are for the first shirt and second shirt respectively. So the first pant, as we can see, can go with both the first shirt and the second shirt, which gives us P1S1 and P1S2. And the second pant and third pant also can go with both the shirts. So P2S1, P2S2. And same is for the pant 3. So the number of combinations for the first pant and both the shirts are 2. For the 3 shirts, there will be 6. With the basic multiplication, we can get the answer. So for every choice of a pant, there are 2 choices of a shirt. Therefore, there are 3 into 2 is equal to 6 pairs of a pant and a shirt. We need to focus upon the choices that are available and the conditions. Now, this is the first concept. If an event A can occur in m different ways, following which another event B can occur in n different ways. So here we are talking about 2 different events which have different ways of occurring. Then the total number of occurrence of both the events A and B is in the given order is m into n. Now, how many 2-digit even numbers can be formed from the digits 1, 2, 3, 4, and 5 if the digits can be repeated? When we look at the question, first we need to check that what exactly is it that we need to find. We need to find the number of ways in which we can form the numbers which are of 2 digits and also even. So these will be our 2 conditions, that the number should be even and of 2 digits. But the options that we have of digits is 1, 2, 3, 4 and 5. We cannot use digits other than these. So options and choices available also become a crucial factor. Now we'll draw 2 dashes because we know that the number is of 2 digit, and at the ones place we can write even numbers 2, 4, 6, etc. But here we can write only 2 digits, either 2 or 4, because we cannot use digits other than these. So here we'll write 2 at the ones place. This 2 is for 2 and for 4. Then we have 5 at tens place because repetition is allowed. If repetition weren't allowed, then we would have subtracted 1 from 5 because one number is already used at the ones place. but here repetition is allowed. So we can use any of the 5 digits given and hence 5 at tens place. Now the next question says find the number of different signals that can be generated by arranging at least 2 flags in order, one below another on a vertical staff if 5 different flags are available. Now the choices or options that we have is of 5 flags, and the condition says that one signal should include at least 2 flags. It can be more than that. So 3, 4 and 5, and of course we cannot create a signal with more than 5 flags because in total we have 5 different flags. So first, when we make a signal that includes 2 flags, neither less than 2 nor more than 2, just 2 flags, the first option that we have is the option for the first flag. We have 5 flags in place of first flag that we can put for creating the signal. And for the second flag in the same signal, we'll have 4 options because one flag is already used by us. So the answer will be 20. Now for 3 flags when we focus, for a signal with 3 flags, the place which includes the first flag will have 5 options because in total we have 5 flags. Then we'll subtract 1 for the second flag and subtract 2 for the third flag because 2 flags have already been used. And same is the case for the signal with 4 flags and 5 flags. Here focus that the answer will be the same 120 and 120. Now then we'll just sum these up so that we can get the final answer, which is 320 signal or ways in which we can arrange flags, at least 2 flags to create signals. This is the second concept. Now, if an event occur in m different ways following which another event can occur in n different ways following which an event can occur in p different ways, then the total number of events in the given order is m multiplied by n multiplied by p. The third question is about a monthly test, and the teacher decides that there will be 3 questions in the test, one from each of exercises 7, 8 and 9 of the textbook. And there are 12 questions in the first exercise, 18 in the second one and 9 in the third one. In how many ways can the 3 questions be selected? So the condition is that 1 question should be there from 1 exercise and total question needed are 3, and the choices or the options available from the first exercise is 12, second is 18 and third is 9. The number of exercises, the name of exercise, that is exercises 7, 8 and 9 is irrelevant here. We do not have to focus on it. We just have to focus on the number of questions that we need to choose and the number of questions that are available. So for the first question we have 12 choices. Second question we have 18 choices, that is the questions from the second exercise. And for the third question we have 9 choices. Therefore we have the answer, that is 1944. Now the fourth question says how many 5-digit telephone numbers can be constructed using the digits 0 to 9 if each number starts with 67 and no digit appears more than once. So here there are quite a few conditions given to us. The first one is that every telephone number should be of 5 digits. It should start with 67. This is the second condition. And the third is that no digit should appear more than once. So we'll draw 5 dashes for the 5 digits to be placed in the numbers. The first one will have just one option, that is 6, because it is necessary that each number starts with 67. And same is for 7. 7 will be at the second place. And the third dash will have 8 options. Originally, the third dash could have 10 options, that is 10 digits from 0 to 9. Any digit could have been placed. But here it says the condition that no digit appears more than once. And we have already used 6 and 7, which are 2 digits. So we'll subtract 2 from the total 10 digits, that is from 0 to 9, and so we'll get 8 digits. and then we'll subtract 1 because one digit is used at this place as well. So the fourth place will have just 7 options and the ones place will have 6 options as we subtract 1.